Solving linear inequalities. In this section, you are going to be looking at inequalities and graphing them and then shading based on what the inequality is telling you. So with linear inequalities, please write both of these definitions down. Linear inequalities are similar to linear equations, but the equal sign is going to be replaced with an inequality symbol. Remember, the inequality symbols are greater than, less than, greater than or equal to, or less than or equal to. So those symbols are going to be replaced with the equal sign for linear inequalities. Also, you'll see solution of linear inequalities, and that is when any ordered pair that makes the inequality true after you've graphed this. When we think of graphing linear inequalities, there are some steps involved, and you need to think of these steps when you're solving examples. So the first step, we're first going to solve the inequality for y, meaning we're going to put it in the slope-intercept form, so in the form of y equals mx plus b. But remember, the previous slide mentioned you are going to be replacing that equal sign with the greater than, less than, greater than or equal to sign, or less than or equal to sign. After you've put it in the slope-intercept form, we're then going to graph what we call a boundary line. And so the boundary line is like our linear line showing and connecting the 2 points, but what's going to take place is you'll have a solid line for less than or equal to or greater than or equal to, and you'll have a dashed line for less than or greater than. So you'll need to pay attention to the inequality symbols with your equations to determine when you graph if it's a solid or a dashed line. And last but not least, when you're graphing inequalities, linear inequalities, we're going to be shading. And what happens when you shade, you're going to shade above the line, above the boundary line for when y is greater than or equal to, and we'll shade below the boundary line for when y is less than or equal to. So let's get into some examples of this so that you can see how this works out. The first example, so we have 4x minus 3y is greater than 12. We need to put this in the y equals mx plus b form. Remember, we will be replacing that equal sign with the inequality sign, which for this one is the greater than sign. So I have 4x minus 3y is greater than 12. I'm going to first subtract 4x to each side. So what I have is negative 3y. I'll write it in the mx plus b form, so is greater than negative 4x plus 12. I need to get y by itself, so I'm going to divide both sides by negative 3. Remember from a previous section, one of the first chapters we learned, when you're dividing by negative value, working with inequalities, you flip the inequality. So I'm now going to have y is less than negative 4 divided by negative 3 is 4/3 x plus 12 divided by negative 3 is negative 4. So remember, I flipped the inequality when you're dividing by negative to make this true. And so I need to graph this y is less than 4/3 x plus negative 4. And when I graph it, this is what it's going to look like. Here, I'll erase this so you can see the graph. Okay, so when I graph this, I start at my y-intercept, which is negative 4. So I put my first point here on the line at negative 4. And then from there, I look at my slope. My rise is 4. My run is 3. So from my starting point, negative 4, I'm going to go up 4, 1, 2, 3, 4, and run to the right 3, 1, 2, 3. I would put my second point. And so from there, I need to draw my boundary line. Since this is less than, there's not less than or equal to. Remember, just less than or greater than, it's a dashed boundary line. So I have my dashed line connecting the 2 points, and then y is less than the rest of this equation. So I'm going to shade everything going down. And this graph represents the inequality. Let's look at the next example, B. Let me erase this so you have room to write. So I need to first put this in the form of y equals mx plus b, again using inequality symbol instead of the equal sign. So I'm first going to add 4 to each side. So I have 2x minus y is greater than 4. And then I'm going to subtract 2x to each side. So what I have is negative y is greater than, in the form of mx plus b, we have negative 2x plus 4. We have a negative y, we need that to become positive, so I'm going to divide both sides by negative 1. Here again, we're dividing by negative, so we're going to have to flip that inequality sign to be less than. So we have y is less than, negative 2 divided by negative 1 is positive 2x, positive 4 divided by negative 1 is minus 4. So now that I solved for the inequality, I now can graph this. Let me show you the graph. Let me erase that inequality here. Write it off to the side. So I have y is less than 2x minus 4. My y-intercept is negative 4, so I start at negative 4. And then my slope is 2, so I will rise 2, go to the right 1, put my second point. Since this is the less than symbol, it's going to be a dashed line. If it was less than or equal to, then that's when it would be a solid boundary line. But it's just less than, so we have a dashed boundary line. And we're saying y is less than the equation. So since y is less than, y is going to be everything shaded down. Which means if I choose any value for y, or any value for x, shading below the line, y needs to be less than this equation combined with x to make this a true inequality. Let's go into example 2. It says Dirk is going to bring 2 types of olives to the Honor Society induction and can spend no more than $6. Green olives cost $2 per pound, and black olives cost $2.50 per pound. They want us to first write a linear inequality to describe the situation. So green olives cost $2 per pound, so we can say 2x plus the black olives are $2.50. So I connect the $2.50 to my y, which equals a total of no more than $6. So combining my green and my black olives, adding that together can be no more than 6. So it can include the 6, but it can't be greater than that 6. So my equation for this is 2x plus 250y is less than or equal to 6. Now I need to put this in the slope-intercept form of y equals mx plus b form. So when I solve that, I would move this 2x to the right by subtracting 2x to each side. And then I would divide 250 to each side. So when I solve for that, my final equation is going to be y is less than or equal to negative 0.8x plus 2.4. So I wrote my linear inequality to describe this situation. I now need to graph the solution. So when I graph it, I'm going to start at my y-axis, which is like 2.4, which is about right there. My slope is negative 0.880x. So I would recommend just doing it the best you can. So you'd go down negative 0.8 into the right 1. Notice this graph is representing my equation based on my green and my black olives, and then I have to give 2 combinations of olives that Dirks could buy. So what that means is when I shade, y is going to be anything less than the equation. So I can pick 2 values, let's say 1, 1, and I can pick the value 1, 1.5. And those two combinations would make this inequality true. So if I said if he bought one black, when he buys one black olive, he's going to have one green olive based on the equation here. And then you just pick points. What you do is you're picking points where the green is shaded, and that's what's going to make give two combinations of olives that Dirks could buy. So you just pick 2 points, and this is the types of olives, the number of olives he could buy to make the inequality true. For example number 3, they want us to write an inequality that represents the graph. So I'm going to look at my first line here. My starting point is at the origin 0, 0, and it looks like I'm going down and to the right 1. So the way I can write this is going to be y is going to be anything which is less than. Now my starting point, my slope is -1, +1, x, and I'm not given a b, a slope intercept, or a y-intercept because I start at the origin 0, 0. So I can simplify this equation to be y is less than -1x, or you could call it y is less than -x. And that equation would represent this line. Remember too, it's going to be less than because we have a dashed line. If this was a solid line, this would be y is less than or equal to -x. For the next graph here, we're going to look and see where we are at the starting point, which is at -3. So we can say y is greater than or equal to, we're going to call it greater than or equal to because it's a solid line. My slope my y-intercept is going to be a -3 because we start at -3. From there, we're going to go up 1, 2, so my rise is 2, and I'm going to go to the left 1, so -1. So the way I'm going to write this is y is less than or equal to -2x minus 3, and this equation represents that second graph.